All right, section 3.5, the algebra of functions. We've got several things we're going to go over here. It all relates one way or another. All of these as you list through them relate to combining functions together to make new functions. The thing we'll spend most of our time with is this last one, composite functions, really. Okay, so let's dive in. The algebra of functions. So the first, there's going to be five different ways we're going to combine functions, and the first four are here. The sum of f and g. So we've got a function f and a function g. They'll write it this way: f plus g of x, and it just means take the first function and add it to the second one. Difference, so f minus g of x, it means take the first function, subtract the second function from the first function, right? F times g of x means f times g. F divided by g, it means take f, write the f function f out, and then divide it by the function g. Okay, so the notation is really just kind of shorthand for what you're going to do. Now, so let's try a couple of them here. All right, so here's the functions, right? We've got our f here is 2x minus 3, our g is 3 over x minus 4, and our h is square root of x minus 2. So we're going to do three different things here, okay? So first, let's look at f plus g, and then I'm going to evaluate it at 10. So f plus g means f of x plus g of x, all right? And then once we have that, I'm going to plug in the 10. So that's going to be 2x minus 3, that's the f, plus 3 over x minus 4. Okay, so that's f plus g, and then sometimes they give you the 10 here, a number to plug in, and sometimes they don't. This time they gave us a 10, so we'll just stick 10 in for the x. Right? So 20 minus 3 is 17, plus 3 over 6, well, that looks like 17 and a half. What about this one, g times h? Okay, well, g is 3 over x minus 4. And we're going to multiply that times h. Okay. Well, I mean, this doesn't really simplify. I mean, I guess you do this. That's about as far as that simplifies. Now this time I'm going to plug in 6. So 3 times the square root of 6 minus 2 over 6 minus 4. All right. So that's 3 square root of 4 over 2, right? 6 minus 4 is 2. Well, square root of 4 is 2. Right? Square root of 4 is 2. So we get 3 times 2 over 2, which is 3, right? The 2's cancel. Last one. H over f. Well, h, again, so that's the square root of x minus 2. That's the h. And f was 2x minus 3. Right? So then we just plug in the 6 for the x. So again, we have square root of 6 minus 2 over 2 times 6 minus 3. All right. Square root of 4. See, 2 times 6 is 12, minus 3 is 9. So that gives us 2/9. All right, that's it for that one. For these kinds, you just plug in what they say. Now let's take a little side trip here. Talk about the way this works, and then you'll see in the next question how we're going to use this. Find the intersection of the following intervals and graph the set on a number line. All right, so we have minus infinity to 0, and then this is a union. Okay, and then this one is an intersection. All right, so let's see how that works. All right, well, this red one here is, the red one here, that's minus 3 to infinity, okay? So this one up here, so minus infinity to 0 union 0 to infinity. So here's the minus infinity to 0. Here's the 0 to infinity. Notice that the 0 here is excluded. You got that open circle. That's because both of these parentheses here are rounded, so 0 is not included in either one, so it's not included in the combination either. Okay? Now, what we're going to do is we're going to take this one, we're going to intersect it, that's the one that looks like an arch, symbol looks like an arch, with the minus 3 to infinity. All right. So if you put those two together, an intersection means you end up with all the points that are in both. It's in the overlap. Intersection really more or less means overlap. Where do the graphs overlap? Well, see, you end up with this, right? So 3 is, this part out here is not included in the second graph, so we don't include it. The 3 is not included in the second graph either, so we don't include that. The 0 is not included in the first graph, so we don't include that. This then is the graph of points where the two overlap. So that's how you do intersection. All right? So let's see where we're going to use this idea. Back up a sec. You see how this is written? So minus 3 to 0, union 0 to infinity. Because we skipped this skips over the, starts at the minus 3 without including it, skips over the 0, goes on to infinity. All right. Finding combined functions in their domains. So what you do, anytime you have a combined function of these first four types, f plus g, f minus g, f times g, f over g, so let's say A is the domain of f and B is the domain of g, then what you do is you intersect them. It's the intersection of the two domains. In other words, it's the overlap of the two domains. With the one little extra that when you do a division like this, you also have to exclude anything that would make, if g was 0, the denominator is 0, right? You can't divide by 0. So it's the intersection of the domains of the pieces you put together, and then also when you're doing a division like this, you don't include it when g equals 0, when the denominator would be 0. So let's use this to do these. So here's an f and here's a g. All right. So I'm just going to save time, I'm going to let the thing tell us. There's the combined function, right? Well, what's the domain? Well, what's the domain of f? Well, what I would say is this. There's ways to do this. The default domain of something is minus infinity to infinity. And then we have two exceptions, all right? If you have an even radical, right? You remember this from before? If we have an even radical, right, where n is even, then what's under the radical here has to be greater than or equal to 0. All right, that's one exception to the minus infinity to infinity. The other exception is that you can't divide by 0, right? If you have a squiggle in the denominator, then the squiggle, whatever it is not equal to 0. So those are the two exceptions. Even radical, what's under the radical has got to be bigger than or equal to 0. And if you have anything in the denominator, that can't be 0. Otherwise, minus infinity to infinity. All right, so let's go back to f. So what's the domain of f? Well, it's square root of x, so that's an even radical. So the domain then is going to be what's under the radical bigger than or equal to 0. And the domain of g, well, there's no radical and there's no denominator, so the domain of g is minus infinity to infinity. All right. Greater than or equal to 0 looks like this in interval notation. So the overlap of these two is just going to be this first one, since the second one is everything. All right. So it's going to be 0 to infinity. All right. So let's see the next function. Nice. Okay. Now then, what is the domain? Well, we've already got the domain of f. You know, this is the domain of f right here, right? And we've already got the domain of g. Right, and we want the intersection of those two. Well, this is the same. This really turns out to be the same as the last one, right? Because it's the same domain of f, the same domain of g, and the same intersection of the two. So we get 0 to infinity, right? Again, there's f times g. Same thing's going to happen, right? Same f, same g, same two domains. You just intersect them, and you get this. Now f over g, there's the function, right? So the intersection of the two domains is going to be this same 0 to infinity, right? But this time we've got an extra twist. The denominator cannot be 0, right? X plus 10 can't be 0. Subtract 10 from both sides, so x can't be minus 10. Well, is minus 10 in 0 to infinity? It's not, right? Minus 10 is a negative number. It would be, it's already excluded from 0 to infinity. So again, we're going to get 0 to infinity. Now, if this had turned out to be x can't be plus 10, then we would have had to make a break to skip the 10. Okay? All right. Composite functions, this is the other way to do things. There were 4, add, subtract, multiply, divide, and now this is the new, the thing that's really completely new in this section. So what they do, so given functions f and g, the composite function f composed with g. Now the book, actually all books seem to like to write it that way. I like the alternate way that we're going to do right here. Here's why. So f composed with g of x is the same as this. This second method is kind of a picture of what's happening. You see the g here is inside the f, and that's just the way it works. All right, so let's work out a couple examples. I'll show you what I mean. So here's f. F is 2x plus 1. G is 3 over x minus 1, and h is that. So f composed with g, right? So f with g in the middle. That means take f and put g, which is 3 over x minus 1, inside of it, right? Well, f is 2x plus 1, so f says whatever you give me, I'm going to multiply it by 2 and add 1. Okay? Now, they're generally going to want you to simplify. I think sometimes on these, it's almost like they forget to ask you to do that. But let's simplify this. We work this out. This would be 6 over x minus 1 plus 1. Then we need a common denominator, right? So 6 over x minus 1 plus x minus 1 over x minus 1. That is going to be x plus 5 over x minus 1. What about this next one? Now this has to say, instead of f first and g second, it's g first and f second. So you just do it in the reverse order. It's g of f. F is 2x plus 1. Now what was g again? G was this 3 over x minus 1 up here, right? So g says whatever you give me, I'm going to make 3 over x minus 1 out of it. So 3 over, now put the 2x plus 1 in for the x, and then subtract 1. Okay? So we end up with 3 over 2x. That's nice. Almost no work to simplify it, all right? Last one, h composed with f, and then it's going to be of 3. Okay, when they give you a number like this, like they've done here, the easiest thing is actually to compute this into a number and then plug it into h. So f of 3 is 2 times 3 plus 1 is 7, right? So that means I have h of 7, which is square root of 7 plus 2, right? Square root of 9, 3. Okay? That is the way the composition works.